finished with two more examples of partial derivatives. We're asked to find partial df dx, partial df dy of these two functions. So let's just do one at a time. So we want the partial derivative of f with respect to x. Now if we're doing that with respect to x, y is a constant. So we want partial of this. Now because we've got y as a constant, that's just like x squared over a constant, so the constant can come out the front. So we 1 over y plus 1 out the front because y is a constant, and then all we've got to do is find derivative with respect to x of x squared. And when we find the derivative with respect to x of x squared, we get 2x. So it'll be 1 over y plus 1 times 2x, and probably a better way to write that is multiply the 2x times the 1 and put that on the numerator, and then that'll be all over y plus 1. Next one is the partial derivative of f with respect to y. So that's partial dy of x squared. Just write it down over y plus 1. Now in this case, x is regarded as a constant, so that x squared can come out the front. Now instead of having 1 over y plus 1, it's probably better off putting that as a negative power. It's much easier to find the derivative when you've got that as a negative power. X squared is a constant. Now we want the derivative of y plus 1 to the negative 1. Now this is a chain rule. We've got a function of a function. So we're going to find diff in, and the derivative of y plus 1 is just equal to 1. And then when we diff out, it'll be negative 1, comes in front of the brackets, write whatever's in the bracket, and take 1 off the power. And if we take 1 off negative 1, negative 1 take 1 is negative 2. You've got x squared times negative 1, so that's negative x squared over, and we say over because if it's to the negative 2, we can put it downstairs to the positive 2. Okay, so that's part A. Part B, we want partial df dx, so derivative with respect to x of x squared e to the minus y. Now once again, if we're doing with respect to x, y is constant, so e to the minus y will all be constant. That'll be just a constant number if y is constant. So e to the minus y can come out the front. Partial with respect to x of x squared, and derivative of x squared with respect to x is 2x. And maybe put that at the front again. So find the derivative of that, you get 2x e to the minus y. And that's the answer to that one. Partial df dy, derivative with respect to y partial dy of x squared e to the minus y. Now if we do it with respect to y, x squared is a constant, so it can come out the front. And that's a constant, so derivative with respect to y of e to the minus y. Once again, it's a chain rule. We're going to find the derivative of minus y, so we'll put the x squared down first though, and then the derivative of minus y is negative 1 with respect to y, and the derivative of e to the minus y then is e to the minus y. And we can then just say bring the minus 1 out the front, and minus 1 times x squared is minus x squared e to the minus y. Okay, so there we've got two examples that are a little bit tricky, but if you just remember the basic rules, it breaks down to be fairly straightforward.